All right, hello there, everyone. This is about 3 or 4 days into me being stuck at home because of Corona. You probably know what that is. Hopefully, it's history by the time you're watching this video. But unfortunately, most all extracurriculars have been canceled, and as such, I'm finding something else to fill that time. That something else will be making random YouTube videos on whatever really strikes me at the moment. What's striking me at this moment is talking about something called gravity vehicle. Now, this is part of the Science Olympiad competition, and Science Olympiad is basically a competition in which there's 30 or so events that team members will participate in, and a team's cumulative score will help them advance on to next rounds for regional, states, and up to worlds. Some events are testing events on science-related concepts. You've got stuff like the machines test, that's a personal favorite of mine, chem lab, fossils, and you have build events. You're making a boom lever to support a amount of weight, kind of like bridge building competitions out of pasta that you may have done. Stuff like that. And one of these competitions is the gravity vehicle right here. This document you're seeing on screen is the rules manual. Now, it'll be up on screen. Pause and read if you want to, or find it on Science Olympiad's website. The reason I'm using this rules manual is the 2019 rules, everything will be the same for 2020's Science Olympiad game. They normally change stuff from year to year, which is why I feel like this is a good time to make this video, because teams can take some of my advice if they find it worthwhile to listen to and use it in their own gravity vehicle. The general premise of gravity vehicle is summed up really well right here where I just highlighted. I encourage you to read that. Basically, you have a vehicle, you have a ramp. The ramp must drop the vehicle, and the vehicle has to go the first 0.5 to 8.5 meter distance as fast as possible, and then it has to stop at a randomly placed point between 9 and 12 meters. Now, this stopping occurs purely of mechanical braking. There's a few different methods to accomplish that, and we'll talk about that in a later video. What I want to focus on in this video is this word right here. Yes, that's the ramp. All right, when it comes to Science Olympiad and ramp types, you've got quite a few. We'll break those up over separate videos. Let's start by talking about one of the most economical ramps out there that a lot of teams will use. If you've been to a Science Olympiad competition and you've seen Gravity Car, you've most likely seen this ramp and been like, bruh, what is it? I'm going to explain that. It'll help. Bear with me. All right. So here are a few sketches of the ramp, side, and front. This one says bad next to it for a reason in which we'll discuss later. And there's a lot of things wrong with this ramp type, but one of the things that isn't wrong is the price. All you need is one or two pieces of wood and something bendy and remotely structurally sound. So what you have is a red and a red. These are going to be your pieces of wood, plywood, and maybe some little piece of 2x4 down here to act as a back brace. And then you've got something that bends. You could look at vinyl, you could look at polycarb acrylic. Maybe if you find the right blend of ductility and stiffness in a metal, go for that. But if you've got that kind of metal lying around, you can probably build something better. All right, here's the general premise. When this ramp is just picked up and not sitting on the ground, which is the blue line you see, when this ramp is just picked up, it actually looks something like this. And you've got your little supports. So that black piece is just something bending and it's free floating, only mounted at these little points up top. When you put on the ground, the black piece bends out. The first issue with this ramp design that you will find is teams cut this black piece too short. Maybe you cut it up here. So when you're bending it on the ground, you do not get a nice tangential transition from the car dropping down the ramp to the car going on the ground. You want that transition to be as smooth as possible in most cases to avoid having the car jut off to one side when it hits on the ground. You know, you've got your front two wheels. One wheel is bound to hit before the other. Thus, the one wheel will go slower right before the other due to its jarring impact, thus skewing the car's direction. You want the car to run as straight as possible and as predictably as possible, because when you're going 12 meters maximum, that is, to hit a point that you must stop at, because horizontal distance factors into your score, you cannot be having any left to right motion off this ramp. There are methods to increase accuracy side to side, and we'll talk about those. But one of the major pitfalls of this ramp that decreases accuracy is having an obtuse angle here by cutting this piece that bends way too short. Next pitfall, see this red dashed line right here? So that line represents the lowest point in which the black bending piece is attached to the red plywood or whatever your backing is. If this line is even remotely tilted, because you're using glue and didn't hear everything properly, or because you messed up measuring where your fasteners were going to be and one of them has Y values, Y being upwards from the ground, that is way too much, then you're going to have issues because the ramp piece will bend. Instead of just a nice smooth curve, you're going to get something all warped. Like, let's try and draw it out here. So if you've got an extreme curve like this, your ramp's going to like do that, and that's a front view. You're basically going to wind up having bulging. You're going to have weird imperfections in your ramp causing inconsistent drops, and it'll be a mess. So my advice is run a little wood screw into your wood or a bolt or whatever on the sides back into your wood at the lowest point you can while still maintaining a nice large radius. And let's talk about this radius. You want the radius to be as large as possible so that way when the car drops, it is not hitting a really sharp compression, and thus if you hit a sharp compression, the car will be influenced by any imperfections in the track a little more. By imperfection, I'm talking about like bumps, little bumps that you might feel but not be able to see. The car will react to those with a sharper compression, and you want to make this radius as big as possible. And this design somewhat limits that. The reason for this is you have to have this little strut piece back here because the ramp is trying to straighten itself out. This black piece is trying to go straight, like down here. So it's actually adding a torque to the ramp like this by pushing down right here. So the ramp's trying to spin this way because this piece is, applying a force on the ground. In reality, it's like right out here at the maximum area. And you could maybe do lever physics on that and all that jazz. Basically, you either have to put a lot of weight up here, which I don't see a lot of teams do for some reason, or you have to have a strut piece back here. And what happens is this strut will wind up taking up just a little bit of space that you need for your nice large radius. Because remember, your radius, if you're using a circular curve, matters there too. And you don't have to use circular curves. You can do something that's almost more parabolic, but I'm still in the belief that a circular curve is pretty much the best you can get with this. And unless you're doing something along the lines of, sharp compression when you've got a little less speed and then slightly more gradual. Remember, now that's taking up even more distance. And you could do that if you're really looking for an equal force on the car and you know how perfect your ramp surface is. But for a lot of teams, I don't think that's feasible. Speaking of which, a lot of teams are like, oh, let's do a catenary curve. And that catenary curve is basically a curve that's between any 2 points in the same plane. It will get something between those 2 points as fast as possible. That's not a catenary because the ball, if you have a ball here and you set it rolling, it's going to go super duper slow along the top, then speed. Something like this, okay, the ball's going to get there between these 2 points, A and B, relatively fast. Your best curve option is going to be something like this. The ball gains a lot of speed very, very fast and then is able to use that speed with just enough gradient to reduce friction. And a lot of teams will actually make their ramp in that shape. You have to remember, this catenary curve in the bottom, the one that I'm drawing over in Sharpie right now, what that's actually doing is it's causing the fastest point from A to B, not your highest exit velocity. You want a high exit velocity because you've got 12 more meters of course. Who cares if you're going down your ramp the fastest? That doesn't matter. You need to be coming out at point B as fast as possible, which is facilitated by a vertical drop. There are a few designs in which you can do a vertical drop in this game because you need to have good contact with your car because you have a vertical drop. It's like you're in free fall and you grab a wall just a little bit, it's going to twist you. Even if you try to put both hands on the wall equally while you're in free fall, you're going to twist a little. Your car is going to do the same thing, and you'll have inconsistent drops. We'll talk more about that another time. Let's finish this design. So, pros, it's really cheap, good to build, great to start out with. Cons, you're looking at mainly ways people build it wrong, from cutting this black piece too short and having it bend into an obtuse angle with the ground, causing jarring transitions. Material imperfections, which can be caused by choosing a ductile material like metal where it dents when you're transporting it. And lastly, improper fastening of the top part, causing a very, very skewed drop. So, this was ramp design number 1. That's pretty good. 4 more to go. 4 more days off, but we will see you guys later.